Okay, so as some of you have already joined, so others I hope will be joining. So I have started recording this session. Okay, so after the last class, do you have any question, any doubt? And you can ask me if you have any question. Anyone? So what we have discussed in the last class, do you recall?
Classification.
Yes.
Cam classification.
Yes, CAM classification we have discussed. Along with that, we have also discussed about the classification of follower also. Okay, so there we have seen just like your like the classification of cam. Okay, so the follower can also be classified based on its shape. Okay, and similarly what kind of motion it is getting. Okay, so if you recall, then apart from shape, then the cam classification we have also done based on the follower movement. That means what kind of movement the follower is getting. So similar is the case. That means whatever, if you are doing the follower classification also, then also what type of, based on the motion also, similarly we can classify those followers also. Okay, so there we have seen like we can have RRR, DRRD, that is rise, return, rise. Okay, that means we can start with rise stroke, then we go for the return stroke, and similar is the case that also. Okay, so this kind of diagram where we show the cam angular displacement along x-axis and the follower displacement along the y-axis. This is known as the displacement diagram for it. Similarly, we can go for like checking what is the behavior of the velocity. Okay, that means some velocity diagram also will be able to draw. Okay, and similar is the case, like we can also have the acceleration diagram. So those things we are going to study next. So later on we have discussed about classification of followers, which can be done based on the shape, movement, and the location of the line. Okay, so there we have discussed about knife edge follower based on the look. Okay, based on the, you can say, shape of the point in contact with the cam surface. Here you can see it is kind of knife edge. Okay, here you can see there is a roller attached. Okay, similar is the case. We can have mushroom follower and all. Similarly, like what kind of motion it is getting, whether it's a reciprocating type of motion the follower is getting, or a kind of your oscillating kind of motion, what kind of motion it is getting. Based on that, we can also classify like reciprocating type as well as oscillating type of follower. Okay, and apart from that, already we have discussed about what is radial follower and what is offset follower. So in the case of radial follower, as you can see, the axis of movement of that particular follower, it passes through the axis of rotation of this particular cam. Okay, and here you can see there is a certain offset between both the cases. Okay, so you can see this is the axis of movement. Okay, and if you look at, then this is the axis of your rotation of this particular, whatever is the cam that we have covered. Okay, so we have got eccentricity in between, so this much is the eccentricity that we have. Okay, so if this kind of eccentricity is there, then we call it as offset type or eccentric type of cam. Okay, so today now we are going to discuss about the nomenclatures of cam profile. So along with cam profile, what are the different nomenclature that are there? So those things today we are going to discuss. So I'll be referring to this particular figure basically. Okay, with respect to this particular figure, we'll be having the different nomenclatures of cam profile. Okay, so now whatever cam profile we are talking about. So what do you understand by cam profile? So by this time already we have discussed about cam profile. We have said that whatever is the motion that the follower gets basically is the, it's a kind of dependent on the look or the cam profile. Okay, or the design of the cam that we are talking about, like that. Okay, so now here in this particular case we are talking, uh, we are going to show the different terminologies involved with respect to a cam with roller follower. Okay, we are talking about this with cam with a cam with, here you can see this is the roller follower that is there, right? Okay, cam with a roller follower. Okay, so by this time all of you can identify which one is the cam here, which one is the follower here. Yes, anyone? So this is the cam here, right? uh, Darken one, and here we are showing the follower. Okay, which type of follower is this? As you can see, there is a roller attached here, so this is the roller follower. Okay, so now all of, what is this? Can anyone tell me what is this? What is this portion as you are showing? This is nothing but this is the portion we are saying, that means here, that means the shaft will fit here, and this portion is nothing but the keyway where will be the shaft will be keyed to that particular cam, so that when the shaft rotates, which will ultimately become the axis of rotation of the cam, whenever it rotates, so along with that shaft, okay, the cam will rotate. Okay, now from this particular look, can anyone tell me this particular configuration of cam and follower, is it the offset type cam and follower or inline or radial type? Yes, anyone?
Sir, radial maybe.
Yes, not maybe, it's a radial, okay, radial or inline
Right.
type, because you can see the axis of movement of the follower will be here and it is passing through the this particular point, okay, center of rotation of this particular cam itself. Okay, there is no eccentricity in between. Okay, had it been here and it is passing through like this and we have got eccentricity something like that, okay, then it will be
Okay.
offset type. Okay, so now the different nomenclature we are going to discuss. The first thing is about cam profile, what we understand by cam profile. So this cam profile, we can say like it is the surface which is in contact with the follower, okay, and that is nothing but the cam profile. Okay, and this is the actual working curve of that particular curve. So now you can see actually this follower actually is in physical contact with this particular surface, this darker one of that particular cam, and which is nothing but the actually whatever is the look or whatever is the contour of the cam, that itself is cam profile of the cam. Okay, that means what is the slope. Okay, so this, as you can see with the arrow have we have been showing, okay, this is the actual profile of the cam and it is the working surface of the cam, because we know for working of a cam and follower mechanism, the follower has to be in constant contact with the cam surface. Okay, and now with this particular surface, whenever it is, if you think of rotation of that particular cam, if it is in this rotation direction it is rotating, then in the next case, okay, like depending on whatever is the position, okay, whatever is the angle that it has moved, okay, so like there, sorry, okay, sometimes it will be assuming this kind of position. My drawing is very bad, drawing in the laptop is difficult. Okay, sometimes it is going to assume this particular uh, console location and all. Okay, so depending on that, this follower will also get the movement and it is actually in contact with contact with this particular whatever is that particular follower. Okay, so now, okay, so that is about follower. Now there is another word, you can see there is a word called as trace point. Okay, as you can see here, so what do we understand by trace point? So the reference point on the follower actually for the purpose of tracing the cam profile. Okay, so when you are going to later on design cam profile, whenever you are going to design cam profile, then this trace point data will be important. So now this is nothing but the kind of here you can consider this is the reference point on the which is lying on the follower for the purpose of tracing the cam profile. Okay, type of follower. So in case of your knife edge, if it had it been knife edge follower, directly it will be this portion would have been kind of knife edge, and directly the knife edge will be in contact with that particular cam. Okay, so in that particular case, if it is a knife edge follower, then the trace point is situated here at the knife edge itself. Okay, and as you are talking about right now, this is the so for roller follower, the trace point is here at the center of the cam. Okay, so
Sir,
now
what is knife edge, sir?
we have some.
Sir, sir.
This is the name of one roller. That is the name of our another follower. Huh? We have already discussed na knife edge follower, mushroom follower, roller
Okay.
follower, like that. So here in this figure we are just showing roller follower. Had it been knife edge follower will be directly in contact here. Yes. So then in that particular case, trace point will lie exactly at the knife edge itself. Okay. Understood?
Yes, sir.
Yes or no? Okay.
Yes, sir. Yes, sir.
So okay. Okay. So now there are some other words like base circle. Okay, so what is base circle? I can call like this. Okay, so base circle, it is the smallest circle drawn from the cam center to the cam profile. So if you consider this is the cam center, okay, so now there is certain profile of the location of that particular cam which is having a constant radius, and now considering that, okay, that's basically with respect to the size of that particular cam, we can draw a circle here. Okay, so the smallest circle from the cam center to the cam profile. Okay, this is the darker portion is the cam profile. Okay, and so this becomes, this circle becomes your base circle. Okay, next there is like one word that is known as the pitch curve. Okay, so now this pitch curve is nothing but a curve which is traced by the trace point. Now this is the trace point, right? Okay, so this is the trace point for this particular case. So pitch curve is the curve traced by the trace point. And for drawing that particular pitch curve, basically what we assume, that we are assuming kinematic inversion concept. That means we'll assume the follower is rotating around the cam. Okay, in normal case we know which one is rotating generally. Generally our cam is rotating, right? Cam is rotating. So in that particular case, what, this is the location of the follower. Okay, and follower will get that particular movement from the cam. Now this is a kind of hypothetical concept for getting the pitch curve. Okay, so we assume that as if the cam is stationary, cam is right like this. Okay, and around the cam, throughout the cam, actually your follower is rotating, and in that particular case you are going to get that particular pitch curve. Okay, so that is this is the pitch curve. So now in case of a cam and follower with a knife edge follower, then this cam profile itself will be, pitch curve will coincide with cam profile, because this trace point will be here for knife edge follower. Right now trace point is here, so this dotted line, dotted one, which gives you the similar kind of look, just like your cam profile, but bigger in size. Okay, this one is the pitch curve. Okay, and there is another word known as the prime circle. So this one, okay, this circle, if you look at prime circle. So what is this prime circle? It is the smallest circle drawn which is tangent to the pitch curve. So pitch curve is this one, right? Okay, so pitch curve we have already shown. Okay, and if here, this will be something like, okay, so this circle will be something like where you'll be able to draw the tangent. Okay, so it is the smallest circle drawn tangent to the pitch curve, and the center will be at the center of that particular curve. Okay, so now if we think of, this is the roller follower. Okay, if you think of your knife edge follower, where directly the knife edge will be here. Okay, or if you think of the flat face follower, where also directly the contact will be made here. Okay, so for these cases, the prime circle and the base circle, they will be similar. So this base circle itself will become the prime circle for the, just like the pitch curve itself is will come like become the cam profile for that case. Okay, and in the case of roller follower, as you can see here, okay, so the prime circle is somewhat larger than that of this particular base circle, right? And how much it is larger? It is nothing but this much. Okay, this much means, what is the amount? Amount is the, anyone can you tell me? This amount is how much? This is nothing but the radius of the roller. Yes, so from here to here, this is, if this is r, then if this is small r roller radius, then in that particular case it will be r plus small r. Correct? Okay, so
Yes, sir.
okay, so now yes, up to here the speech particular point on the pitch curve. This is the pitch curve. Okay, this one. Yes.
So nothing, just before it was echoing. So.
Okay, so pitch curve, pitch point now. Okay, pitch point is the point on the pitch curve of the cam where basically maximum pressure angle you will get. So there is an angle that is known as pressure angle. So pitch point is associated with that maximum angle. Okay, so now we'll see which one is what is pressure angle and all. Okay, prior to that we'll also discuss this particular angle known as the cam angle. Okay, so now what is this cam angle? So basically cam angle is nothing but the angle of rotation of the cam for a particular displacement of the follower. Okay, if suppose initial position is here, okay, from here to here, if it is rotated, this is the, okay, then this much is the cam angle. Okay, so whatever is the cam angle or x1 angle, so this is the similar case, how much it has rotated for a particular displacement of the follower. Okay, now here in this particular case, as you can see, we are with a dotted line, we are showing some another position of that particular follower itself. Okay, so in that particular case, in actual case, even the follower is here only situated here and the cam is actually rotating, so we are saying that for kinematic, we are just considering the concept of kinematic inversion, and for showing the different you can say nomenclatures, okay, elements, so we are assuming as if the follower is rotating around the cam. So in that way also we can get the shape of that particular cam, because later on if you need to design the cam profile, then also this concept will come into handy. We'll assume as if the follower is rotating around the cam just in the opposite direction of the movement of the cam. Then what will happen? So if constant contact is there, which is a requirement, okay, so constant contact also will be there, and if it is rotating around the cam, then actually whatever is the shape of the cam or the profile of the cam, okay, so it is going to trace that kind of thing only, okay, but in a larger size, depending on whether it is a roller follower or if it is a directly knife edge follower, directly it will follow it like that. Okay, so now that is about the cam angle. Okay, now before coming to pressure angle, let's consider some other words. Okay, let's see like pitch circle and all. Okay, so this is the pitch circle. Okay, now already pitch point we have heard. Okay, pressure angle will discuss, no problem. So pitch circle, it is the circle having center at the center of the cam, that is this is the center. Okay, and the radius equal to the distance between the center of the cam and pitch point. So we have said that up to this much, this is the pitch point, so taking this as the radius, is your pitch circle. Okay, so similarly we know that during the course of or course of working of that particular cam and profile. So basically we designed the cam to give certain displacement or certain lift to that particular follower. Okay, follower gets certain displacement. Okay, and that particular displacement depends on what is the type of work that you need to do. Okay, so requirement of that, you're based on your requirement, actually you design it. So now this lift or stroke, this word, okay, this is the similar kind of word that we use. Okay, lift, or sometimes we call it the different strokes. Okay, so this lift is maximum lift or lift is just, or the stroke length also sometimes we call it. Okay, lift or stroke length, this is the maximum travel of the follower from the lowest position to the topmost position. Whenever it is suppose at the lowest position, then there will be suppose the lowest lower level of that particular you can say whatever is this particular profile. Okay, so let's consider this one. Now, whenever the follower cam moves and assumes this position, okay, because it is constantly moving. Okay, so in that particular case, as the constant contact of the cam and follower is there, so follower will move up to this much. So there will be a maximum lift. Okay, that is a maximum portion that it will get up. Okay, so that is nothing but lift. Okay, so it is the maximum travel of the follower from the lowest position to the topmost position. And in this particular case here, this maximum lift is, in this case it is this AB, this portion. Okay, so because why? Because from here to here, actually, if this radius, if you consider R, this is also R. Okay, so this is also kind of R. Okay, so throughout this angle, actually it is constant radius, R equal to constant, right? So there will not be any movement. So ultimately that means if we hypothetically if we will draw this, okay, then the up to this much there is no extra lift, so maximum lift possible is here. Okay, amount is AB. Okay, similarly we have already discussed yesterday about dwell or period of dwell, that word. Okay, okay, dwell or dwell period. So now what is that, or period of dwell? So it is the period during which the follower is remaining stationary during some finite rotation of that particular cam. And generally where we generally get the dwell, okay, whenever we encounter a constant radius curvature. Okay, so like in this particular case, that means here to here, let's consider it is time is rotating. Okay, and whenever the cam is encountering, the follower is encountering this portion of this particular cam, okay, where there is no change in this particular size. Okay, so constant radius curve. Okay, so during that time there will not the follower will remain at that position itself. Okay, if you consider as if, let's consider it is rotating in this direction. Okay, now after some time, for some time, okay, depending on what is the angular velocity, it is going to encounter this portion, that shaded portion, that red portion of the particular cam profile itself. Okay, and during that time, the cam is actually rotating. Cam is having a finite displacement, angular displacement, but the follower will remain here itself. Okay, whatever is the previous position. So that time is nothing but dual. Okay, so after this much, all of you have understood the different nomenclatures. I'll be providing you the uh, this data. Don't worry. Some notes I'll be providing you. I hope you have understood after this one.
Mhm.
Okay.
Yes.
So now comes to this important nomenclature, that is the pressure angle denoted by generally phi. Okay. So now what is this pressure angle? So this is the angle between the direction of motion of the follower. So if you consider this portion, okay, this location of the follower, okay. Now which one is the direction of motion of the follower? For this case, this is this one. Okay, assuming the follower has assumed that particular location now. Okay, so it is a angle between the direction of motion of the follower and a normal to the pitch curve at any point. Okay, and this is the tangent that we have drawn to the pitch curve, and 90 degree to the pitch curve will be normal to the pitch curve, right? So that means this one. Okay, and this angle between the direction of motion and the normal to the pitch curve is nothing but the pressure angle in this case. Okay, and what does it basically represent? So now see, you can see, depending on what is your requirement of that particular motion requirement, you are going to basically design a cam profile. Okay, design your cam. So cam means that shape of that particular working surface cam profile. Okay, so now there will be certain stiffness that might be there in that particular like cam. Okay, cam design. Okay, sometimes the cam may look something like this also. Okay, I can, okay, let's put this one so that maybe sometimes it may look something like this, kind of very steep. Okay, so right now here it is somewhat oval shape, not like this. Okay, so now you can see for all the cases, this number one, number two, number three, all the cases. So there are certain if you follow those curves, okay, that's the cam profile. If you follow, okay, so you can see the stiffness is different. Okay, so here you can see, if you compare this and this, okay, the stiffness is different. Okay, so now this pressure angle will give you the indication about it will represent the stiffness of the cam profile also. Okay, and this angle is very important in while designing the cam. Okay, why? Because during a complete rotation, so this particular pressure angle, it is going to vary from some maximum value to the minimum value. And like if you go for high value, there is a high value of pressure angle that is being encountered. So during that case, if the pressure angle is greater, so the side thrust on the bearing, etc., which is supporting that particular follower, okay, so that will also be kind of high. Okay, and generally what we do, so maximum, we try to limit this particular phi value. Okay, sort of like within 30 degree. Okay, we want to limit within 30 degree. So generally, if this phi exceeds 30 degree, okay, at angle 30 degree, so then a reciprocating type of follower, which is this case, okay, reciprocating type of follower, it will jam in the bearing. Okay, and it also, that's why generally we keep it lower than 30 degree. Okay, so for being safe. And if this particular pressure angle, it also depends upon the what is the angle of ascent, the lift of the follower, what is the follower motion, what kind of offset if it is there. Okay, so and because of that, if as it is having so many roles to play, most probably, importantly, regarding the limitation of the side thrust in your work, and apart from that, jamming that particular bearing, etc. Okay, so this is, everything is dependent on this particular phi, that is the pressure angle that we are talking about. That's why we want to keep it minimum as possible within the limit. Okay, it should be within the limit, and limit definitely allowable, maximum permissible limit is there, and we want to keep it within the limit and as minimum as possible. Okay, we don't want to increase it. Okay, understood? Let me know whether you have understood or not. So these things I will be providing. Okay, okay, let me know. I hope I yes. Okay, thank you. So
Yes,
now there are some other. Okay, thank you. So there are
yes,
some
sir.
other words also. Okay, okay. So there are some other words also like the angle of ascent, which is the angle during the ascent stroke. Okay, ascent stroke means going up. Ascent means going up. Descent means going down. Okay, so we have seen that depending on whatever is the cam profile. Okay, so the follower, if you're thinking of a reciprocating type of follower, okay, it goes up. Okay, during certain interval of time, during certain cam rotation, which is known as the ascent stroke. Okay, and sometimes it remains at that particular portion known as the 12, and after that there will also be a fall or the descent going down. Okay, that is known as the descent stroke. So ascent stroke we have also known as the ascent stroke or outstroke, and then we have the dual. Okay, dual stroke, that means when there is motion on that particular cam, but it is encounter the follower will not have any motion. Okay, so and descent means this is going down, and we also have angle of action. Okay, so now with respect to figure we are going to discuss it. So whatever figure generally we have been always drawing, okay, the simple one, the well shaped one. Okay, okay, and there we are showing a knife edge follower here. Okay, so with respect to this we are going to draw. So now the base circle I can draw. This is the center of the cam, center of rotation of that particular cam, and we can draw the base circle, the smallest circle considering the center here, and we have to also go through the or pass through the cam profile also. So this is the smallest circle. So here you can see from here to here, this portion, that is A to D, this angle here also is a kind of constant radius. It is the part of this particular circle. Apart from that, here it is gradually increasing, here also gradually increasing, or this side if you think gradually decreasing, you can consider like that. And from B to C, once again you can have, okay, so this these are, if you think this dotted line, this from center if you draw here. Okay, basically once again this is a constant radius. Okay, understood? And this is the knife edge follower that
Yes,
we have, and this mass is your leaf or the lift of the follower. Okay, so now which one is one what we are calling as angle of ascent or dual or descent, etc. So now angle of ascent, so this thing we can discuss in terms of angle or in terms of period or time also we can discuss. Okay, so because we know it is what kind of motion the follower cam is having, rotational motion. Okay, that means a certain omega it has got. Okay, and if it has got omega, that means we already know s, just like in the linear case it is s equal to vt, so here theta equal to omega t, right? We already know. So now if I know like the this one, okay, and we can very easily say, suppose for going through or for traversing a particular like angle, how much time will be required. So these two can be like either theta or t. Okay, either angle or time. Okay, so in terms of this they are similar. Okay, because for traversing a particular angle it will assume or it will consume a certain time. Okay, that is they will be connected. Okay, so now this angle of ascent is the angle of rotation of the cam from the position when the follower begins to rise. That is, ascent means going up. Okay, so when the follower is beginning to rise till it reaches the highest position, that particular angle is angle of ascent. Okay, so here in this particular case, this is the, if we draw the displacement diagram where we show cam angular rotation theta along the x-axis and the lift of the follower along the y-axis. So if we discuss here. So here you can see for the duration, that is theta a angle, what is happening, the lift is from zero position to the maximum, it is we are getting the lift. Okay, so this angle, so for which there is the lift from follower begins to rise, okay, and it assumes the maximum position, so this angle is theta a, that is angle of ascent. Okay, understood? So here it is denoted by angle, and AOB is the angle of SN in this particular case. AOB. Okay, it is gradually, whenever it is encountering this portion, gradually it is increasing. AOB. Okay, so and we are saying that this is the that stroke is also known as outstroke or angle of SN. SN stroke, outstroke, they are having the same. Okay, so from A point to B point, so follower starts lifting. Now from B to C, what happens? You see, B to C, once again it encounters a constant radius, right? So constant radius means, will there be any lift on that particular follower? It is encountering constant radius. Will there be any lift on that or displacement of that particular follower? Will it be there? No. Okay. So that means during that time, this, okay, no, yes. So this angle will be known as the dwell angle, and in terms of time, if you discuss, then it is the dwell period or time of dwell. Okay. So that means now whatever is the previous position of the uh, follower, there itself it will remain. Okay. So let's consider this is the dwell angle. Okay, from B to C. Now in that particular case, previously already it has assumed this, that follower has already assumed this position. So now there will not be any, for B to C, there will not be any movement of the follower. So wherever it was there previously, it will remain here. Okay. Similar is the case now from C to D, if you consider. So it is somewhat similar to A to, while it is going from A to B, but it is now going down. Okay. So this angle, in terms of angle, once again it will be known as the what angle? Your angle of descent. Okay, theta d, denoted by theta d, or what is happening here? So the follower is gradually moving down from the upper position to the lower position, right? Okay, so that is the dual. Okay, and after that, from D to A, this person, from D to A, this particular person, once again it is a portion from the circle itself. Okay, that means once again constant radius. So will there be any motion? Will there be any motion in the follower from D to A?
I think no, sir.
Or ultimately you can answer maybe D to E if you have completed this. Okay, so from here there will not be once again no motion. That is once again that is the dual. Okay, so that is dual. So you can draw, now the position is here. Okay, follower has already gone down. So now here you have to darken it, and so that means there is no motion. Okay, so now this completes one complete revolution. Okay, and that is the thing. Understood? So this is the case. So the same thing has been written here. And the total angle covered by the cam during its rotation between the beginning of the rise and end of return is nothing but the angle of action. Okay, so so this thing you have understood.
Yes.
Okay, thank you. Okay, so now we have said that previously. That means the follower can also be categorized based on the movement of the follower. Okay, what kind of motion that we give. And now we know by this time that means this cam and follower used for getting certain complicated motion which cannot be otherwise easily obtained by other type of mechanism which are generally available with us. Okay, so now the output motion, which one is the input, which one is the output? Cam is the input or the output?
Cam is
Yes, correct. So cam, it's the input motion is given in the cam, and we take the follower, whatever motion follower is getting, depending on the profile of the cam, that is the output motion. Okay, and we are mostly interested in the output motion, what kind of motion we are getting. Now, for analysis purpose, if we can have certain standard type of motion on that particular follower, then designing of the cam becomes easier for that particular type of motion. Okay, now we'll see what are the different types of motion that the follower can have. Okay, so now a follower can have these motions, like we can have uniform motion or uniform velocity. Then we can have SHM motion, that is simple harmonic motion, that can be obtained on that particular you can say follower. Okay, that is a standardized kind of motion. We can also have uniform acceleration and uniform retardation, that kind of motion on that particular follower. These are all follower motion that we are talking about. Okay, we are talking about the follower motion, not about the cam motion. Okay, we can also have cycloidal motion. These things you have studied in your uh, engineering drawing. Okay, how which one is cycloid, epicycloid, hydrocycloid, etc., etc. So those kind of standard motion we can have on that particular, we can make on that particular follower. Okay, and apart from that, any other kind of desired motion, that is definitely possible with the help of your cam and follower. Okay, that is one of the sole motive of utilizing your cam and follower. But the thing is, if you can get work done by having the follower motion in any of the standard motion, then for that it is standardized, already standardized, and certain standard way of designing the cam is available for this kind of motion. Okay, so this is also possible. Getting any type of desired motion is definitely possible, but it is somewhat, task is somewhat complex. That's why knowing the knowledge, having the knowledge of this standard motion and utilizing them also is important. Okay, and apart from that, this motion, this standard motion or any kind of desired motion, whatever we have been talking about. So these motions can be utilized singly. Okay, that means throughout the whole operation, it can have only suppose one of this particular motion. Let's consider suppose SHM. So throughout the operation, it may work and in SHM motion, or you can also have a combination of with one another. Let's consider suppose SN stroke you are accomplishing with SHM, and let's consider suppose descent stroke with uniform acceleration or uniform acceleration. Okay, so that is also possible. Okay, and from there, if we are talking about those motion, then understanding its displacement and higher derivative of displacement, that is high velocity, and understanding the acceleration behavior of this is very, very important. That's why we can draw, and we generally draw three different types of curves, and that is known as, or three different types of curves. Okay, we draw the displacement diagram, three different diagrams. Displacement diagram, then the next higher one is the velocity diagram that we talk about, which is coming from the displacement diagram. And next higher derivative of displacement with respect to time, we already know it's the acceleration. So we know, we draw about, or we talk about also the acceleration diagram. So basically, in the next classes, subsequent classes, we'll be talking about drawing, how to draw the displacement diagram, like acceleration diagram, velocity diagram, and acceleration diagram for different cases. Okay, so as we have said that uniform motion or uniform velocity can be there. That is the simplest one. Uniform motion means like when the follower is traveling the same distance in its time succeeding time interval, then it is the uniform motion. Okay, so for that particular uniform motion, drawing the displacement diagram, velocity diagram, and then your acceleration diagram is somewhat easy. So as we have already discussed, so displacement diagram, along the axis is what we take for drawing the displacement diagram. We consider the cam angular rotation, and along the y-axis we consider the displacement or the lift of the follower. Okay, so now we know there are right stroke or out stroke. Okay, and there is dual stroke and there is return stroke or the return stroke. Okay, or descent stroke you can say. Okay, so right stroke, then ascent stroke. Right stroke is equivalent to ascent. Okay, right stroke is equivalent to ascent stroke. For pardon my handwriting. Okay, right stroke is equivalent to ascent stroke equal to out stroke. These are having all same name, same meaning. Okay, names are different. Similarly, we can have descent stroke, and that is also known as the return stroke. Okay, descent stroke, descent stroke, or return stroke. They are having the same meaning. Okay, so if someone uses the words like right stroke or ascent stroke, they're the same thing. Okay, or descent stroke or return stroke, you should understand that. Okay, so what happens? Right stroke, follower goes up, descent stroke, follower moves down. Now, what is the type of motion we are talking about right now? We are going for uniform velocity. That means for each succeeding time, actually, our follower is getting the same lift. Okay, at its succeeding interval of time. Okay, so if we let's consider the whole 360 degrees from here to here. where we have got the rise stroke, then the dwell, then the return. Once again, that is dwell. So let's consider from here to here. This is the rise. From here to here, this is the dwell. From here to here, this is the return. And once again, at the end, we have the dwell here. Okay. So now in the rise stroke, what is happening? We are showing along the y-axis the displacement of the follower. So follower will gradually move up in a straight line fashion up to this much. Then we are talking about we are having the dwell. So in the dwell there will not be any displacement of the follower. So already it has assumed this position. So this is a horizontal line here. Okay, and after that with uniform velocity it is going down. That's why 45-degree descent is the slope will be 45-degree only. Here also it is 45-degree. Okay, so this is the return stroke, and after that there is once again dwell. So this is okay. So this is how we have drawn the displacement diagram. Okay. So the other things that we are already showing here. Okay. What how we draw. Okay. So next, this is about we are talking about what type uniform motion. Okay, or uniform velocity of a football. So that's why the look is something like this. Okay. Next, while drawing the velocity, displacement velocity and acceleration diagram, always you should draw like this. Okay, you just project those point. Okay, so then it becomes easy. Don't use different separate pages there. Okay. Now from A to C, it is the right stroke. Okay, and what is the velocity? It is uniform velocity. So uniform velocity, and after that C to D from here to here, if you project. Okay, so this is the this is dual. Really, which delta we represent dual. Okay, dual strokes. Okay, if you just project it, this is the return stroke. Okay, so okay, sorry. Okay, so now in that particular case, so from A to C, that means it is with uniform velocity, it is going up. Okay, so that means from A already, so we'll be drawing along y-axis the velocity and along x-axis one against the angular displacement of the cam. Okay, so now from here to here, that means some velocity is there, uniform velocity from the. So this is a kind of hypothetical concept from the zero. From the very beginning itself, we are showing some uniform velocity. So it has got certain uniform velocity from here to here, that means. Okay, and we have to complete this particular blockwise. So now from C to D, from here to here, that is the dwell. Suddenly we have to drop it, and in the dwell there is no motion of that particular follower. That means velocity is zero. So it is dropping to zero. Okay, so we have to darken this. Okay, we should not now draw here, but from here to here. Now after that, once again, it is the return stroke is there, and but the direction of movement is different. Okay, previously it is going up, now in the return it is going down. Okay, now it is once again uniform velocity. So what we are saying, to show that it is in two different direction, this and this. Okay, and what we are doing now, once again we have to give some velocity here. So this is the velocity value. Okay, this one is the v. Okay, this is the v. Okay, and from here to here it has go. Now once again after that there is del, so suddenly it has stopped. Okay, and there is no velocity. Okay, this is the velocity diagram. And how to do up to this much, is clear? Displacement diagram, velocity diagram, how we are drawing.
Yes, sir.
Let me know. Okay, thank you. Now the third derivative, that is the next thing that we are left with. We should also know, understand about the acceleration behavior, how it is doing. So once again, we'll just project those points. Okay, so in the similar case, okay, whatever is the stroke direction. Suppose this is the A point, C point, D point, corresponding points. Okay, G point, etc., etc. Now what happens? This acceleration means what? This is x. We can consider this displacement. So we know dx dt equal to v, right? Velocity equal to dx. That is rate of change of displacement with time. So how it is changing? Rate of change of displacement. It is uniformly changing. So that's why uniform velocity. And what about acceleration? Acceleration means rate of change of velocity. Yes, dv dt. Right? That means how velocity is changing with respect to time. Okay. Now, can you tell me if from the initially it was at zero velocity and suddenly at this instant itself it has to get this particular finite velocity v. Okay. Now, what will be the rate of change? At an instant it's at zero. At that very instant, I am saying that it is getting some velocity. So, at what rate it is getting the change? At infinite rate, right? Yes or no? Here itself it was 0. If you look at the A point, so at the A point it is starting from 0. At the A point itself it has reached up to certain velocity. As if it is 0, and let's consider this is 10. From 0 to 10 it has reached within no time, okay, at 0 time. That means infinite acceleration it has got, right? So at this point that means it is infinite acceleration. That's why what we are doing at A, we are showing with a cursor to infinity. We are writing, so this is the acceleration diagram. We have to show acceleration along y-axis and displacement along your x-axis, okay, acceleration y, okay. So suddenly that means it is, okay. So now after that there is nothing, no expression and all, so throughout that similar case. Now once again if you look at C, this portion, so here it was having some velocity, and all of a sudden at the C point itself it is the dual, it has started, and 0 velocity, 10 to 0, within no time it is coming. That means deceleration, that means in the opposite direction, that is also infinite deceleration is there, retardation. So at this point we are showing with the opposite direction cursor to infinity, deceleration to infinity. Okay, now dual is suppose over, so no problem. Now after here the dual ends, okay, and the return stroke starts here, okay. But once again you can see suddenly it was having 0 velocity. At the same instant we are saying we are also drawing some velocity is there. That means once again acceleration is infinite, okay. And similar is the case in the last case, okay. From some acceleration it becomes 0 after this, okay. So retardation is there, okay. And this direction we have just changed to show the two different, okay. That means is the this is the right stroke, this one is the return stroke, okay. And what is happening here, these things I am writing, I have mentioned whatever I have been discussed here is being written here, okay. So this is how we draw the displacement diagram and the velocity diagram and the acceleration diagram for uniform velocity of the follower. Okay, understood? Let me know. So this will be the thing for today. We'll stop here. Let me know if you have understood or not. If any confusion, you can ask.
Yes, sir.
No. So all of you have understood, okay, uniform velocity concept. So here you have seen this is basically kind of theoretical. That means all of a sudden I can say that right now I am like in this moment itself I am stopping here, okay, like I am here, and at this moment itself I have reached up to suppose like 10, I am stopping here, okay. At that distance itself I am reaching was 20 kilometer per hour that speed. Is it possible? Actually not, okay. It will get certain time, it will take certain time, okay, but to reach that value, okay. So that means this particular case is actually kind of hypothetical, so there will be some modification that will be required so that to get a finite value of acceleration, because getting infinite acceleration is not possible. So in the next class we will see the modified displacement velocity and acceleration, okay. So for today we'll stop here. Respond to your name calls. Paul,
Prince, sir?
Shankar,
Yes, sir.
Arsisman, absent. Rehan,
Present, sir.
Partha Patir,
Present, sir.
Rishikesh Basumotari, absent. Hermiki,
Present, sir.
Nohasul, Teza, absent.
Yes, sir.
Rishikesh Nath,
Present,
and
sir.
Emil. Okay, so we'll stop here for today. Thank you everyone
Thank you,
for
sir.
joining.
Thank you, sir.
Yes, sir.
Thank you, sir.